Today topic is formation of energy bands in solids. Bloch developed the zone theory, and according to this theory, the electrons moving in a periodic field provided by a crystal lattice. This theory, also known as band theory of solids, and successfully explains the classification of solids into conductors, semiconductors, and insulators. In an isolated atom, the electrons are tightly bound and have discrete energy levels. When two atoms come close, one energy level split into two energy levels. As the atoms come together to form a solid, they interact strongly. By interaction, the positive nucleus of one atom attracts the electrons and repels the nucleus of adjacent atom and vice versa. As a result, the single energy level split into n energy levels for all n isolated atoms. The group of these energy levels is called energy band. In general, n interacting atoms cause an energy level to split into 2l plus 1 n energy levels. For s orbital, the splitting is 1n energy levels. For p orbital, the splitting is 3n energy levels. For example, if you take lithium atom, the electron configuration is 1s2 2s1. Here the 1s shell is closed and there is only one electron at the 2s level. In solid lithium, 1s band is corresponding to the 1s energy level, 2s band is corresponding to the 2s energy level. Both 1s and 2s bands have n levels each. 1s band is completely filled as 2n electrons occupy n energy levels, whereas the 2s band is half filled, because the n available electrons fill n by 2 lower energy levels in the band, leaving the upper n by 2 levels vacant. Such half-filled energy bands at the top belong to the group of conductors. Therefore, lithium considered as a good conductor. In case of silicon, the electron configuration of silicon atom is 1s2, 2s2, 2p6, 3s2, 3p2. Here the inner K and L shells are closed and the corresponding bands would be completely filled. The outer subshells 3s and 3p, the 3s subshell is closed and 3p subshell is partially filled. Here the isolated silicon atom has discrete energy levels. As the separation between the atom decreases, the 3s and 3p levels split into two bands, and now there is a gap between the bands. At the energy gap decreases with the decrease in atomic spacing. At this position, the band merge and form a composite band. The 3n upper level merge with n lower levels, giving rise to a total 4n levels. These 4n levels occupied by the 4n electrons. At the lattice constant, the composite band branches out, and once again two bands are formed, separated by a Fulbright band gap energy. Therefore, the band gap energy for silicon is nearly about 1.12 electron volt. Coming to classification of solids, based on band theory of solids, we can classify the materials into three categories: insulators, semiconductors, and conductors. In case of insulators, the band gap energy is greater than 3 electron volts, and the electrical conductivity is also very low for insulating materials. Electrically insulators, for example, glass, rubber, wood, plastics are electrically insulating materials. In case of semiconductor, the band gap energy is very less than 3 electron volts. For example, for silicon 1.1 electron volt, for germanium 0.7 electron volt. In case of compound semiconductors, cadmium sulfide, the band gap energy for cadmium sulfide is about 2.1 electron volt. And coming to the conductors, the conduction band and valency band overlap to each other here. There is no band gap energy in case of conductors. Here, the coming to the electrical conductivity. The electrical conductivity is very low for insulating materials, and the conductivity of semiconductor is in between the insulators and conductors. The conductivity is very high for electrical conductors, for example aluminum, silver, gold, copper, nickel, etc. Thank you.